dry weight of each VG30 is 320, 700 pounds when it was completed under the racing configuration. Careful attention was taken to quarantine the electrical systems to prevent a crossover engine failure. This was one of the Achilles heels of the entire project. When the project was handed over to Steve Hinton over at Chino, they had to move the black boxes and electromagnetic type things, and they were just coming up with problems left and right. During the development process, the engines received new headers and a new intake plenum. CG on the Pond Racer is located 7 inches ahead of the firewall. Pond Racer used 2 highly modified counter-rotating Hartzell King Air propellers that were 76 inches in diameter and turned at 2,200 RPM, just under Mach 1 to keep the efficiency where it needs to be. After completion of the primary aircraft structure, the aircraft was handed over to Dick Rutan, who made the first flight on March 22nd, 1991. Pond Racer pilots, only 4 pilots ever flew it. Dick Rutan, Mike Melville, Steve Hinton, Rick Brickert. Those are the only 4 pilots that ever flew the Pond Racer. Again, we talked about how it was similar to landing a MiG-29, so you better be a good pilot to land it. The flight test program, Dick commented that the flying qualities of the Pond Racer were good, they were superb, and that control authority was very good. Here we see Dick sitting in the cockpit. This is after a recent test flight. Photograph Dick is seen exiting the aircraft after another successful test flight. Here you see Dick filling out the logbook. And it's a tight fit in the Pond Racer, only a ½ inch clearance on each of the pod walls there, so it's a very tight fit. Here you can see the detonation primer cord. This is used for emergency pilot egress, so if you had a problem, one of the options was to bail out. Now, Rick chose, it was decided in him, he decided that he would rather try to ride it out rather than bail out and get hit by the vertical stabilizer. So that was his decision. Due to a relatively high wing loading, the pilot doesn't really bounce around in a racing configuration. So that was one good thing. Major design goal was to not run the engines at 100% power to be competitive. Also, it was designed so that these engines could be readily replaced. A lot easier to find these VG30s than the Merlins that we see today. Onboard computers direct the operation of the fuel injection system, ignition system, prop controls, and turbo wastegates. Dick Rutan, the Pond Racer program, an estimated $3.5 million was spent on the program. I think it's significantly more than that, but the published factor is $3.5 million by Mr. Pond. Now, Rick Brickert, he piloted the Pond Racer between 1991 and 1993. He was an Air Guard fighter pilot, commercial airline pilot for Delta Airlines, and an air show pilot T-33 Red Knight at Wendover, Utah. Shot of Rick after he won Reno with the Dreadnought. And again, you can see kind of the glider-like fuselage pod section of the Pond Racer here. This is a photograph of Dick and Rick inside the maintenance hangar at Reno. And here we see them sharing a moment at the mic at the air races. Once quoted as saying that he would rather ride it out in the safety of the pilot's compartment rather than to try to bail out past the vertical stabilizer. So again, this was Rick's decision on the Pond Racer. Qualifying speeds at Reno, 1991 were 400.010. 1992, it was 364.978. So those are the 2 qualifying speeds. Rick described the flying qualities of the Pond Racer to be that of a jet fighter with light rudder pedals. Now, during 1993 Reno, during a qualifying run, as Rick was increasing manifold pressure, the starboard engine seized on him. He called a mayday, went up into the vertical, and at that point was going to set up an emergency landing, but there were 2 Hawker Sea Furies blocking his immediate runway, so he chose to do an off-field landing. He brought the gear down. This is from eyewitnesses who saw that, and hopefully some of you can clarify. He retracted the gear, brought the gear back one more time, and then brought the gear up into the engine nacelles. And then from here, according to Dick Rutan, due to the seizing of the starboard engine, some of the coolant lines were severed, and they got into the cockpit section, which was very difficult for Rick Brickard to deal with. Now, he opted for an off-field landing. He crashed into this rough terrain here, bounced once, and when the aircraft came down again, it burst into flames, and unfortunately, we lost Rick. I don't think that this should have happened. This could have been prevented. Here you see the right engine nacelle, and the aircraft was really basically totally destroyed. The remaining pieces are now at Steve Hinton's hangar at Chino. The official NTSB report states that oil starvation and connecting rod failure to the right engine and a resultant fuel-fed fire. So this is the NTSB report. This is what they're saying actually happened on the crash of 1993. Now, what could we have done? What should have been done to prevent this? Significantly, the most important thing that could have been done is a completely different engine selection. That's the most important thing that could have been done. Obviously, that was the heart of the problem. So your options are a Pratt & Whitney PT6A-42, which is an 850 horsepower turboprop engine. The only problem with that is turboprops are not allowed at Reno. You have to have a piston reciprocating engine to compete at Reno. So we have to cross out this engine. By definition, the only other engine that fits this requirement is the Michael Zucca Turbo Diesel Series. The only other one in the world that reaches that spec. Now, it has a whole host of advantages over the current piston engine designs. For instance, the engine has half the specific weight, half the frontal area, and burns less fuel. Very low noise emission due to two-stroke and turbocharging. No electronic interference, very low vibration level. One power lever only, no mixture, no alternator, no aux fuel pump. No magneto or spark plug problems. No belts, no gears, no bearings. No rubber hoses. I mean, this is incredible. This is the engine for this aircraft. So what I proposed is to take the 8-cylinder radial turbo diesel by Michael Zucca, which produces 300 horsepower, do a double row radial of 600 horsepower, 16-cylinder, which is 25.5 inches in diameter. We're maintaining the original diameter. It would be small enough to fit in the Pond Racer. So by default, in my opinion, this is the only engine that could have ever been put in the Pond Racer that could have made it successful. Now, we know that never happened, but theoretically, that'd be the only way. Some of the cutting-edge air racers, we have the Bugatti 100, which John talked about, did a fantastic job. The Pond Racer, the Nemesis NXT, the VMAX Pro by Lars Gertz. We have the Renaissance Racer. We have the Intrepid, the Mach Plus, and the ARA Racer by Skip Holm. The Mach Buster, a 19.5 wingspan, length was 33.5 feet. Supercharged Oldsmobile V8 producing 1,400 with an estimated top speed of 710 miles an aircraft. The aircraft never flew. It was on display at Reno, designed to use a NASA SR-3 propeller, 4-blade carbon fiber of 65 inches in diameter. And due to lack of money and some stress analysis, vibration was determined that it would never have flown under that condition. So this project was scrapped, and it never went any further than that. The Intrepid Air Racer, wingspan is 35 feet, length was 38 feet.